My name is Mónica Aguado. I am the Director of the Energy Grid Integration Department at CENER, a department that in 20 years has its focus on contributing in technological challenges to follow the increase of renewable energies penetration into the electrical system. Over the years, we have been adapting to the specific needs that the grid presents in general in the face of the growth in these energy sources. The year 2010 will be remembered as a milestone for the department due to we commissioned Atenea Microgrid, the place where we are today. The government of Navarra, together with the European Union, provide us with the necessary financing for the development and start-up of this facility, under the premise of having a plant that could show the viability of this type of solutions, as well as having a test bench for all the technologies involved. Microgrid compromise low voltage distribution systems together with distributed generation sources, as well as storage systems. They can work both in connected and isolated mode. The microgrid is no longer an aggregation of loads and microgenerations operating as a single system that provides both electrical energy and thermal energy. The Atenea microgrid has renewable generation and conventional generation. As renewable sources, we have installed a 20 kW full converter type 2 blade wind turbine and 25 kW of photovoltaic panels on the roof. As conventional generation, we have a 55 kVA diesel generator and a 30 kW gas mix turbine. Our microgrid is electro and thermal microgrid. As storage systems, the Atenea microgrid has a range of technologies that allows us to have a versatile and configurable installation depending on the type of the plant we want to reproduce or test. We have 50 kW lead acid batteries with 2 hours of storage, a 50 kW lithium-ion battery half an hour, a 50 kW vanadium flux battery 4 hours of storage, and finally a bank of supercapacitors of 30 kW 45 seconds. We have too an electrical car. The Atenea microgrid is connected to the distribution network and can operate both in connected and isolated modes, supplying not only to our resistance and inductance bank itself, but also for lining the LEA offices as well as the industrial estate itself. But all equipment would not make sense without an intelligent system that allows it to function and make decisions about what to do with energy to all time. The Atenea microgrid has an EMS system integrated into a PLC that allows, depending on predictions of the resource and the demand, to send the set points to each of the equipment to respond to the loads. This system optimizes energy both from a technical and economical point of view, including aspects of maintenance and useful life of each of the equipment, especially of the storage systems. This installation has been the starting point that has allowed us to know in depth this type of installations and, what is more important, develop technology around it and demonstrate the feasibility of the new paradigm of the electrical system. Over the years, we have been able to test in the microgrid from microgrid systems to large storage systems. We have been able to work on the development of hybrid storage solutions. We have worked in the management of diesel groups. We have tested and validated the operation of different plant configurations. It has also allowed us to develop a profit grid containerized solution to provide supply based on renewable energies in isolated or remote areas or where there has been a network outage. The Atenea microgrid has allowed us in the past, allowed us in the present, and will allow us in the future to continue researching and developing knowledge and technology in the field of smart grids and storage systems, with the ultimate aim of achieving the objectives of a total decarbonization of our society.